Hello students, in this video we'll discuss about finite automata with epsilon transitions, or simply we can call it as NFA with epsilon transitions. So in the last class we have discussed about the NFA examples and how to convert an NFA to DFA. So with the subset construction and also with the shortcut method what we have constructed directly without the useless symbols, right? So then first of all, what does it mean by epsilon transitions? See, sometimes there is a requirement of moving from one state to another state without taking any input symbol or without receiving any input symbol. So in such cases, the states can be combined by using the epsilon edge, right? So of course, the power of everything is same, guys. NFA with epsilon, NFA, DFA, minimal. The power means the number of languages accepted by each and every type is same, but where it is going to be different means the design complexity of the language. For example, if you are asked to construct a finite automata for a language where the any number of A's followed by any number of B's followed by any number of C's, assume that we have like that, okay, or any number of ones followed by twos or six. That's your wish, whatever you want to take. I just cross verified what we have taken in the next slide. Okay, so what is required to us in our automata? Any number of A's followed by any number of B's followed by any number of C's. That's it. Once you take B's, you are not supposed to take the A's again. Followed. You take how many number of A's you want here, then B's, then C's. Then you can go for it. So first state is any number of A's followed by any number of B's followed by any number of C's. This is the final state. And you have to take it like epsilon or okay, you may get it out. Sorry, before that, let me go with this. Sorry. Any number of A's. So you have to combine the states, right? Yes. But what is the problem if I use the A here and B here, right? A here and B here. See, the minimum strings where A is followed by B is followed by C is, I can take a single A, but that is not allowed here. The minimum string is AB. Even I can take a single BC, but you must take the A here. So now what will be happen here? If I keep some symbols on this edge, so it is not satisfying all the strings. But if I won't keep anything, single A accepted, single B nothing, B nothing accepted, single C nothing, nothing accepted. But if I write some symbols like BC, single A is not accepted, single B is not accepted, single C, it's violating the rule, right? Then how can it do such things? See, now if I won't write anything here, but it is satisfying. So then there is a requirement of adding a moving from one state to another state without reading any input symbol like this, right? So there is a requirement of moving from one state to another state without reading any input symbol. Such transitions can be represented with the epsilon. So that is the significance of epsilon, right? So same here we have taken some states, okay? Then 0 or more A's followed by 0 or more B's followed by 0 more C's. I could have given this diagram directly, but what is the use of it? I told you. Sometimes there is a requirement, right? So then we can construct this transition diagram like this, okay? You have to take an epsilon move here, right? You're going to have some epsilon move. Then you're going to have A, B, C. What are the states here? Q or S. QA we are going to A, QB no state, QC no state, Q epsilon we are going to R. Same way, RA no state, RB R, RC no state, R epsilon S. SA no state, SB no state, SC we are going to S, and S epsilon no state. We are not going anywhere. So this is the transition table for NFA with epsilon transitions. So as I told you in the last slide, the power of NFA with epsilon moves is equivalent to NFA without epsilon and DFA. Then how to convert it? So how to eliminate the epsilons? So here, guys, whatever the diagram we have taken here, this is the NFA with epsilon moves and it is denoted with the transition. Now you have to convert this into the NFA without epsilon moves, right? Without epsilon, then it should have only A, B, and C, like this, no epsilon, and we can call it as extended transition. Remember here, while you are converting an NFA with epsilon moves to without epsilon moves, there is no change in the number of states. But I told you from NFA to DFA, if you are having n states, in DFA you will be having maximum of 2 power n, but here there is no such concept. The number of states same. Here this is transition, this is extended. Now what it is? Transition of Q comma A, we are going to A. Then after removal of epsilon, if I read QA, where should I go? That I have to find. At here I can write like this. On Q, if I read A, I am going to the state called Q. Sorry, this is Q. This is a transition. But transition, extended transition. On Q, if I read A, where should I go? That I have to find. This one. Here, what is the difference between the transition and extended transition? You have to write the epsilon closure after and before every input symbol. That's the only difference between transition and extended transition. Means here QA means from the normal transition, read the A, but before A, take any number of epsilons, take any number of epsilons. We can say that this is epsilon closure. So first step, apply the epsilon closure on Q. Second step, read the A on the resulting states. And third step, again apply the epsilon closure. Means you can write like this. See, extended transition of Q comma A will be having. The first and foremost step is what? Epsilon closure on Q. Then you can write like this. Epsilon closure on Q, comma. Second step, what you have to write here. So you have to read the A on the remaining input symbol, the resulting input symbols, whatever we got here, the state, sorry. That's the second step. Read A on the resulting states, whatever you got from the E closure of A. And again, third one, again you have to apply the E closure on the resulting states or epsilon closure on resulting states. See, this is a formula. If it is Q naught A, you write Q naught A. If it is QB, write QB. RA, same thing. SB, write SB. This is a formula. I could have given this directly, like how they have given in the right. But see, I explained it, how we got it. Q naught B. Epsilon closure, this is also epsilon closure. Right? The epsilon is denoted with this. How it is going to be done, right? Same thing. But I gave you the formula, how we got it, that formula also. So first you have to find the E closure of the states. So what is the E closure of a state? Right? Before going to that, the E closure of a state is nothing but how many states I can go without reading any input symbol from the Q. From Q without reading, I can go to Q with 1 epsilon R. From Q with only 2 epsilons, I can go to S. That's it. No other state. Same way, what is the epsilon closure of R? I cannot go to Q with the epsilon. Can't go. I can go to R and S with 1 epsilon. S, I can go to S. That's it. Right? So as I told you, no change in the states, right? But there is a change in final. So from Q, if I can reach the final state, I can make this as a final state in the NFA without epsilon. From R, if I can able to reach the final state with only epsilons, then I can make it as a final state. From Q, I can reach the final state with only epsilon. So that's why same. Then how to convert it? See, there is a result. Then how to eliminate this? So let me write the first one. Okay. So epsilon, right? Let me go with 1. At least 1 will go with that. So first, as I told you, you can go with the diagram where it is going to have the three states. So R, Q0, Q1, Q2. Then you can go with 0, 1, 2. We already find the E closure. I just changed the input symbols and state names. E closure of Q0 is Q0, Q1, Q2 because from Q0 I can reach epsilon Q2. Then how to do it? This extended transition, right? Extended transition of Q0 comma 0 is nothing but just copy the formula here, whatever we have taken. Just change here, last, at here, whatever we have taken, just change here. Q0 comma 1. Just replace it. You'll get it. Then you can write E closure of Q0 comma 0. First, what is the E closure of Q0? Apply it. Q0, Q1, Q2. Then you can go for it. Epsilon closure of Q0, Q1, Q2, comma 0. Then apply it. Read 0 on every state. Epsilon closure on Q0, comma 0, union Q1, comma 0, union Q2, comma 0. So epsilon closure of what is Q0, comma 0? We are going to Q0, union Q1, comma 0, no transition. Q2, comma 0, no transition. Then Q0 union empty set, you will get the E closure of Q0. What is the E closure of Q0? We have already got Q0, Q1, Q2. Then you can write here Q0, Q1, Q2. That's it. Same way you replace with 1. 1. E closure is right 1, 1, 1. Q0 1, no state. Q1 1, Q1, Q2 1, no state. Now empty set union Q1 union empty set, you'll be having Q1. And epsilon closure of Q1 is Q1 comma Q2. Then you can write it. And same way replace with the 2. That's it. Here you will be having, see, this would be the final automata. For example, if you want this, let me take it. So epsilon closure of Q1 comma 0. It is nothing but epsilon closure of, I'll write like this, epsilon closure of Q1 comma 0. So what is epsilon closure of Q1? You can take it Q1 comma Q2. Then you can write epsilon closure of Q1 comma Q2 comma 0. Read 0 on both. So epsilon closure of Q1 comma 0 union Q2 comma 0. So what is a Q1 comma 0? Epsilon closure. Q1 comma 0 is empty set union empty set. Then you'll get epsilon closure of empty set. It is nothing but empty set. That's it, how we got it. Just do it and represent it as a diagram. After conversion, you can represent it as diagram. Right? So we are having here Q0, Q1, Q2. So what is the final state here? Q2 is already final state. Now from Q0 I can reach the final state with only epsilons. So I can make Q0 is final state. From Q1 by reading only epsilons I can even reach the Q2. Then you can take it. Q0 0 where we are going? Q0, Q1, Q2. 1 where we are going? Q1, Q2. Q1, Q2. 2, Q2. Right. Q1 0 no state. Q1 1, Q1, Q2. 1, 1, 2, Q2. Q2, 2, Q2. 0, 1, like that. So you can try this one more, right? Like how we have taken this. Finally, you'll get it. Try it once. The remaining all, definitely you'll get it. So in the next video, we'll discuss about the regular expressions and properties, right? Guys, here you have to write all the 9 transitions. I just explained only 1 or 2, but in exam you are supposed to write all 9 in this way, not the way how we have done it. I mean to say that like how I wrote epsilon closure something, right? Not